Bueno, ahorita voy
No, de Gitlab.
a hablar, bueno, esto es un curso básicamente de Git, ¿no? La introducción, vas a aprender a instalarlo en Windows, a instalarlo en Linux, y básicamente que te lo voy a dejar, este curso es un curso que también lo puedes encontrar en Udemy, pero aquí te lo voy a dar totalmente gratuito, sin costo alguno, así que aprovechalo, espero te sirva, y ya sabes, si te fue útil, si te fue de utilidad, compártelo, dale like, suscríbete al canal, por favor, ayúdame a crecer, y nada más que decir. Ahí te dejo el curso, ¿no? El curso está en inglés, por lo cual está subtitulado en la parte de abajo, entonces ahí te lo dejo, pilas.
Already, let's say, pretty weird and pretty detailed for beginners. So finally going to install. Okay, so that's about it. One of the tools that come bundled with this installation is the so-called Git Bash. So I'm gonna click here to launch Git Bash. This is like another terminal window that helps you interact with Git. Let me make this a bit larger. Alright, so now we can double check again that indeed we have Git installed, and you should see something like Git version, whatever is the latest version. For this tutorial, we'll be using Linux Mint, but for any other Linux distribution, the steps should be pretty similar. But just in case you have any issues, leave me a comment in the section below and I will add more details to this video description. So let's get started. What I want you to do is to open a terminal window and simply type in the command git or git-version to see what's happening. So in my case, Git is not installed, and I'm even suggested here which command I should enter in order to properly install Git. So this is exactly what I will do. I'm gonna be asked for my password. I'm gonna confirm that I want to install Git, and probably in just a few seconds, the entire installation process will be over. Okay, so if I type in the exact same command once again, we'll see now that Git has been properly installed. I've opened up a terminal window. Any terminal window that you have inside macOS works. The first thing that we want to check is to see if you have Git installed. So I've opened up here a terminal window inside macOS, and the command that I'm going to type is git-version. And what I will get back is my Git version. And this already comes with my Xcode installation. Now, in case you're not getting here Git version and you're getting an error, then there's still an additional step you need to do. I'm here at git-sem.com, and you will see here information regarding downloading and installing Git for Windows. Now, what I'm using is I'm getting Git because I've already installed Xcode from Apple. So you can download that from the App Store. But just in case you're not into that, the alternative that I recommend is using Homebrew. Now, Homebrew is a very nice utility. It allows you to install a lot of these packages and tools that you need during your development efforts when you're using macOS. It's pretty simple. In any terminal window, you just copy this command that you see here. You'll go through an installation process. And essentially, once Homebrew has been installed, the command that you need to run is brew install git. Super simple. And then it will install git. That's all it takes in order to get this to run. And if you can, I would highly recommend that you install Homebrew. Before we are getting started with learning Git, let's make sure that we are on the same page. Open a terminal window and type in the command git --version. If you are on Windows, I highly recommend you open the Git bash terminal for following along with this course. In my case, I see my current Git version, but if you don't see your current Git version, if you see an error or anything else, it typically means you don't have Git installed. Please check the video description for the tutorial that will help you install Git. This depends from operating system to operating system, and we really don't have time to get into that. Come back here when you see that version, but you will find all the information in the video description. So if you see that version, let's continue. In this first part of the tutorial, we will focus solely on Git and not get into Gitlab yet. The first thing is to create a Git repository. And here's just a quick pill of theory. I'm working at building this small website, and I have this folder, and I want to keep track of the different changes. The system that I have used so far is to copy the entire folder and append something like version 1, version 2, version 3, and so on. This is not great, but it works. Git offers a better way of keeping track of the changes by using repositories. A repository is a place that stores something. A Git repository stores files and keeps track of any changes. This is why all software projects are using a version control system like Git. We want to be able to keep track of all changes, see who has made them, and if needed, have the possibility to revert to a previous version. It also helps integrate the work that multiple people do without much effort, but we will look into that a bit later. So let's get started by creating a new Git repository. Now, what I want to do first is to create a new folder, and if I already have a folder containing some files for which I want to use Git, that's totally fine. So I'm going to use the command make directory, and my directory will be called my cool website. So this directory has been created. Now the next step is to change the directory and go inside that folder directory, as you want to call it, that I've just created. And in my case, this directory is totally empty because I just created it. Now, the first or most important command that you need to know about Git is the following: git status. This is the command that we'll be using throughout the course. And trust me, Git status is your friend. Whenever you are lost or don't know what exactly is going on, you can use Git status to understand what's happening and know what to do next. So even though we don't have a Git repository at this point, we're going to run this command git status and we'll get some information. So first of all, we're getting an error back and it's telling us this is not a Git repository and this is what's going on. So for the moment, we don't have a Git repository here. So that's already a good thing. In case we had a Git repository, this will look totally different. Now the command that we need to run in order to create that Git repository is called git init. So this will initialize a new repository and it will tell you here initialized empty Git repository. It's empty because it doesn't have anything inside this folder here that I created. And this additional folder that you see here, .git, this is typically hidden. You will not be able to see it. So for example, if I run here this command ls, listing all the files, it will not show you anything. But if I add another parameter that will show me hidden files, you will see here that we have this hidden Git folder. Now, essentially, this repository is something that is self-contained inside the folder that you have. So this is something that you can easily copy, transfer anywhere you wish. It's not connected to any external server or anything like that. It's just a file system, and Git knows how to read those files and to offer this version in control. Now, as a regular user, you don't need to worry about that folder. You don't need to make any manual changes to it or anything like that. So next, let's run the git status command again and see what's happening. The next step here is, you will see, it doesn't show an error anymore. It shows here on branch master. Master or main is the default branch. We're going to get into branches a bit later, but essentially, regardless what you see, master or main, it's absolutely the same thing. It contains the main branch of development. This is where you typically have the version that you want to use, to put it like that. Okay, so now we have everything that we need in order to start interacting with this repository. If this is the first time you are using Git, we still need to configure a few things before we can actually start tracking changes with Git. And I said previously that Git helps us track changes, but also to identify who has made these changes. In order to have this properly configured, we need to tell Git essentially who we are, and we do that by configuring a username and an email. Essentially, every change that you make and track with Git will be marked as made by your name and by your email. This is just the way how Git works. And we're in a collaborative environment, you'll be able to tell who has made a change. And, in a team, you can directly go to that person and ask for the details in case something is wrong. So it helps a lot to identify who made which change and why. And this is the way this tracking works. So the command that we're going to use is git config. And there's this parameter that we're supplying. So this is a global configuration, and we're setting the user.name. And typically the username is your first name and last name. And it is important that you configure this, otherwise by default it will be your machine name. And if you're starting making changes on a repository where other people inside your organization work, they will, give you funny looks because you haven't configured this properly. So it is an important step. So I've configured this. Additionally, the next line that we'll be configuring is the email. So this is also global configuration, and this will be user email. By the way, you can easily copy paste this from the course notes that are available. We don't want you to make any mistakes here. So this will be your email address. If you're in an organization, use your company email address. I'm just using something for testing purposes here. Right, so now we have configured Git, and we can get started with the rest of it. Now it is time to create your first Git commit. Commit is like a snapshot of the repository at a point in time. So let's see how you can create your first commit. The command that we'll be using for creating a commit is git commit. And if I'm running this command, it will tell me you're on branch master and there's nothing to commit. Nothing to commit simply means you haven't made any changes to this folder where the Git repository is. Essentially, we haven't added any files, we haven't changed any files, we haven't deleted any files. And from the initial state, which contains no files, nothing has changed. So it kind of makes sense that we have nothing to commit. So let's go ahead and start creating a file. Now I'll be using the terminal here to create files, but feel free to use Explorer or Finder or whatever else you have to go inside this folder to create a file and start making changes to it. So I'm using the Vim editor to create a file called readme.md from Markdown. And with I'm gonna be in insert mode, and I'm gonna write something like, hello, this is my first commit. Super simple. With escape, I'm gonna exit this insert mode. With column, I will activate here this command line here, and with X, I'm gonna save and exit. So now essentially, if I'm looking inside this folder that I have, I will see that I still have the Git folder, and now I have this README file. So let's run again the Git status command, and now I have this README file. What's going on? What's the current status? So let's run again the Git status command, and now I have this README file. Say that we don't have any commits. And additionally, what's happening now is that we're getting some information here about untracked files. And this discussion about untracked files is a bit different. I'm gonna go through the steps once, but essentially, untracked simply means that these files are not prepared to be committed. They're not prepared to be added to Git. And Git does not work like a Dropbox folder. You know, anything that you put in the folder will automatically be added to Dropbox, uploaded, and secured. This is not how Git works. If any change that we make to a folder or to a file would be added as a revision, we'll have a mess in terms of history. This is why we are talking about committing. We are making some changes. At one point, we're deciding, now I want to commit, and what I'm committing here is something like purposeful. It's something that I want to keep the history of. Now, in order to commit this file, we have to go through this adding step. And it's even saying here, we have to use git add and then specify the file. So I'm just going to do exactly that, git add. And the file that we're trying to add is readme.md. Now you would think that we now have made a commit. Well, that's not what happened. So if we run git status again, we'll see that something has changed. And what has changed is the following. This is no longer appearing as an untracked file. This is in a secondary stage where we prepare the changes that are about to be committed. So it goes through these changes as follows. First of all, we have made some changes to the folder. By default, they are not part of the commit. And then we transition those changes into this stage. And this stage is called the staging area. It's a stage before we actually commit something. And this is the next step. After that, we can commit this. And there's a reason for this two-step process, which I'll explain in one of the upcoming lectures. But for the moment, let's just get this commit ready. For the moment, I'm simply going to write here my first commit ever. And hit enter. So the next step is to go ahead and actually create this commit and to supply the commit message with what we have. So I'm going to write here git commit. And with -m, I'll be able to supply here a parameter. And this is essentially the commit message. So my first commit. And now we have created our first commit. If I go ahead and run git status again, we'll be able to see that in the folder, I don't have any other pending changes. I'm still on the same branch and there's nothing to commit. Let's now take a look at how we can commit multiple files. So to do that, we first have to create a new file and also make changes to an existing file. So let me go ahead, because I'm working at my website to create index.html file. And this is going to be very simple. So this is not HTML course, but essentially I'm just going to write here some code. So essentially a super simple HTML website. I've added this file. And additionally, let's make a change to the README file. So I'm simply going to add a new line. Change itself doesn't matter. So let's now go ahead, run git status, and we'll see the following things. Now, we have made changes to a file, the readme.md, and this file is already being tracked by Git because previously we have staged it and we have committed it, so Git knows about it. And the other thing is this index.html file that we don't know about. So we also have to, if you want to commit it and have it tracked by Git, we also have to add it to the staging part and then also to commit. So now what we can do essentially is we can go ahead and type in something like git add and then readme and then index.html and so on. So there are multiple ways on how we can do this. We can do it for each individual file. Most of the time, if you change multiple files, you don't want to go through all the files. So there's the possibility of going like this or going git add -- all. There's one possibility, or much shorter, git add and write a dot. Now, at this point, you're probably wondering why is it that important to have this staging process? And the reason for that is it allows you to modify multiple files at the same time, but to create commits for individual files or for a group of files. Typically, we try to organize the commits in a way that it makes logical sense. In this case, I created this index.html file, which contains the website, but also made some changes to the README file. So you could say that these changes are not correlated. They're not together. Working on a website has nothing to do with, changing some documentation or general information. So if this is the case, we can make the changes to the README file, then make a commit. And of course, we are taking that README file, we are staging it, and then committing it. And then we can take the index.html file, we bring it in the staging area, and then we commit it. So this staging area is really important because it allows us to be very selective about the changes that we want to commit at a specific point. It allows us to select what we want to commit and what we don't want to commit. And this is why we have it. Otherwise, everything that would be modified would be automatically committed if we didn't have this possibility of saying this will be part of the next commit. So with that being said, in this case, I can commit everything that I have inside here. But I will also show you what you can do in case you don't want to commit both files. So now let's try to remove something that we have staged. Again, if you're looking for additional information to understand what's the current status of this repository, what has happened right now, we'll get this information by running git status. And it will tell us that if we're running a commit right now in this moment, there will be two changes that will be committed. We'll commit the index.html file and also we'll commit the readme.md file. One is a new file, but the other one has been modified. So we can, of course, have multiple files in a single commit. Now, as we said, we don't really want to have this commit containing both files because especially when we get to that message, like why are we making this change? Well, we have modified some installation instructions and also changed the website title. So when we're coming to this kind of difficulties formulating a logical and simple commit message, it's an indicator that you're probably committing too much, and later on when you're looking at the changes, you will see that they're actually not related with each other. They're not necessarily to, fix a bug or add a new feature or something like that. So fortunately in this case, git status is also giving us some information like, okay, you have staged these files. But just in case you don't want this, you want to unstage one of these files, that's not a problem. You can simply run the command git reset head. This is just a reference to the current head of the repository. It's like the latest version of the repository essentially. And stage doesn't mean that the changes that we made to the README file have gone away. So if I'm running this again, you will see here the changes to be committed. It's only the index file that will be committed first. So let's go ahead, git commit -m. This is the message. Let's say added first page. So now I'm adding here the first page. This has been committed. I'm running a git status. I can see which is the current status, and we still have modified files. So every time we are modifying some files inside the folder where we have git, this information will come up here. Hey, you still have some other files. So that's totally fine. We can go ahead, we can just use git add dot. This will automatically add any changes. So we know exactly what's been modified. With git status, we have an overview over what we're committing. And especially in the beginning, I highly recommend that you use this git status command a lot, so that you understand what is Git doing, what is happening, what are you committing in the beginning, so that you understand, oh, these are the files that I'm committing. Oh, why I'm committing that file? I don't want that. Let's remove that. So this is how things work. So now again, commit -m, and this is like improve readme. Doesn't really matter so much. All right. So now running git status again. We still have all our files, but all the changes that we made are now inside Git and are being tracked. So now we already made some changes to this repository. We have added some files. So if we want to have an overview over what has changed, we can use the command git log. So what git log will tell us is essentially a history of what we have. And you will see here we have 3 commits. The first commit, then I added the first page, the index HTML page, and then I improved the README. You can see at which time and date this commit has been made. Additionally by, in this case it was only me working on this repository. So this gives you an overview of what has happened. As you can see in this case, it doesn't give you a lot of information. So there are additional flags that we can set, for example, git log --patch. This will give us a bit of additional information. Like in this case, I added here a line, you can see here with plus, I am learning Git. So this is what has changed comparison to the previous version. If you're looking at the next commit, you will see here that I completely added a new file. This is the content that I've added. In the first commit, you can see that I've added a README file. Now, this is like an additional parameter that you can use with a git log. Now, most of the time, especially for software projects, there will be multiple files involved, and these files tend to be relatively large. So I would say it's useful to use git log in the terminal just to have an idea of what's going on or to verify if something was committed indeed. But in most cases, you'll find yourself in an IDE looking at the entire commits and the changes and the diff between the changes, but it's still an important command to know. Let's now take a look at how we can commit a folder. And this is something that a lot of people I know is struggling with and doesn't understand exactly what's happening. So for example, if you have a Dropbox folder and you create a folder, that folder will be synchronized all over the place. But now if we create a folder, let's say temp, so we've created inside here a website folder, you can see here my index.html, readme.md, and temp. So this is another folder. Now if I'm running a git status, this is the confusing part, it will say nothing to commit. And the reason for that is Git only tracks files. Git doesn't track folders. Now, this doesn't mean that you cannot create folders and you can still organize your entire project in multiple folders. But if a folder doesn't contain anything, that will not be tracked by Git. So in order to keep track of a folder, if it doesn't contain anything, if for whatever reason you want to keep track of its contents, the convention is to insert there an empty file. And the name of that empty file will be git keep. So it starts with a dot. In most systems, this will be automatically hidden, so you don't even know it exists. but you create this git keep file there. It's an empty file. And essentially, because it is a file, you'll also keep track of the folder itself. So we create it inside temp/git keep. Touch is just a quick command allowing us to create an empty file without worrying too much about it. You will see now that when running git status, we'll see here that we have some untracked files. So we can go ahead and track. Let's see what we are adding in this case. And you will see here now we are committing this file. So we're not committing the folder itself. It has detected that we have there a new folder. But essentially, when we added this, whatever we had with git add all, we are committing this file. So let's go ahead, git commit add temp folder. So this is just a temporary folder that we have. Just in case you're seeing this .git keep file, you should know why it is in there. Next, let's take a look at how we can delete files when using Git. And in this case, it is very important to make the distinction between files that are already inside Git and files that are not inside Git. So let's call them untracked files. Now, for untracked files, that's pretty simple. So for example, if I create a new file, let's call it here new file.txt. And we're looking here inside and we're seeing it. New file.txt. And if I'm running git status, you will see here, oh, you have an untracked file. This is, of course, not part of Git yet. So if it says untracked, not part of Git, Git doesn't know about it yet. So if you want to remove this, you can simply go ahead and remove it. So new file.txt rm, and it will go away and will no longer have it inside here. Git didn't know about it. So it's super simple. It's more or less the same as when you delete a file from your folder. Now, if we're looking at the list of files that we already have inside here, if I, for whatever reason, decide to remove this temp folder, which also contains the git keep file. So I can run here rm, and I can specify here the temp folder. Now, if we're looking inside here, this temp folder and the file that it contained no longer exist. But in this case, Git has them in the repository. So if I'm running here git status, this deletion of the file from a Git perspective will only happen when we're actually telling Git about this. And the way we're telling Git, just as when we're adding a file or we're editing a file, removing a file is also a Git operation, it's also a commit. So of course we'll have to use here git add. So we're staging this change that we want to make. In this case, it's a deletion. We're also giving a name for the commit. So this is what happened here. We have also deleted the file and the folder git keep, the temp folder and the file git keep, both from our file system, from this folder, and also from Git. You can also look here at the git log, and we'll see here that we have removed the temp folder. So that's a regular commit. Next, I wanted to explain to you how to handle a situation where you still need to have some files inside the folder, but you don't want to make them part of the Git repository. Let's create a directory called config. So I have here a directory called config, and let's say inside this directory I have some, private information that I don't want to share with anyone. So private.txt. So this private file is something that I just want to keep on my computer. I don't want to track it. I don't want to be part of the repository. Now the problem is if I have such folders there. First of all, when I'm running git status, I will always be in this status where I have these untracked files. And additionally, I also have the risk that when I'm making a change, if there are untracked files and I'm using git add all, that I'm also adding these changes to the repository, which I don't want to do. Now, fortunately, Git has a way to get around this. And this is by defining a file called the git ignore file. So let me show you what I mean by that. So I'm going to open up an editor, .git ignore. And this is a configuration file. It has to be inside your Git repository. And essentially here you can define files or folders that you want to ignore. So in my case, I want to ignore this folder called config. I'm going to save this. And it has been saved. So if I'm running git status again, well, I will have an untracked file, and this is the git ignore file, and this needs to be part of the repository. But as you can see, it's no longer saying anything about this config file, but obviously this config file is still there. And this approach is quite common, so most software projects will have a git ignore file. Let's say if you're working on a JavaScript project, HTML and JavaScript, super common to have inside git ignore the node modules. Any dependencies that you're downloading locally, there's a lot of things that you don't want to have part of your Git repository. So this is why this git ignore file is super important. And the next step here is to simply commit this change, actually to add it first. Git commit. I'm gonna say here simply added. So this is the git ignore configuration. Git status, again, super clean. There's absolutely no risk now that I commit any sensitive changes that I have inside my config file. So far, we have made all our changes directly in this master branch, or you may find it as the main branch. Main and master are absolutely the same thing. The tendency is to move toward using a more inclusive term like main and leaving master behind. It's slowly changing. By default, a lot of these Git repositories that you find online like GitHub, Gitlab, they will have the default branch main, just in case you're wondering like what's the difference though. So far, we have made all our changes inside the master branch. And the thing is, we typically don't want to make these changes directly inside the master branch. Maybe sometimes we're working at a new feature or trying something experimental, and we still want to take advantage of Git, like keeping track of the changes, going back to master, making some changes there. So for that reason, we have this concept of branching. Now, branching is essentially when you're diverting from the main development flow, which is in master, and you want to make some changes, you want to keep track of the changes, maybe you want to share these changes with others. So in other words, you're still using Git, but you're not affecting the main development branch. Just in case you're wondering right now, what we're going to do is to create a branch. And let's say I have this crazy idea to build an HTML table, and let's see how it's looking like. And I don't want to do it directly in master. Maybe I have to work on it for a few days. I want to keep track of the changes that I'm doing. So I'm going to go ahead and create a copy of this repository. It's essentially the same as when you have a project, you don't want to ruin it, but you want to try something out. So you make a copy of that project. This is essentially quite a similar concept there. So git checkout -b. So this is how we create a new branch. Then we have to specify here the branch name. So let's say I'm creating here a table. Most of the time you will find a prefix for the branches. So for example, if you're working on a feature, you're going to write something like feature / new table. Or maybe if you're fixing a bug, an issue, maybe you write something like bug fix / new table. It really depends like how these things are used internally. I'm going to just call it feature / new table. And what's happening now is we have changed our branch. So we are no longer inside the master branch. I'm having this very nice terminal. It's always telling me what's going on. Probably if you don't have this configured, it will not look like this. You'll know exactly what's going on. So we're gonna run the command git status, and you will see here your branch feature / new table. And there's nothing to commit here because we haven't made any changes. So super simple. Let's go ahead and modify our index.html page. And I'm gonna create here a super simple HTML table. I still need to to learn a bit how to write this in HTML. So maybe I'm gonna stop for a bit after some work. I'm gonna add this change and I'm gonna go ahead and commit it. All good. So if I'm looking inside that file, I'm gonna see here my website and also the table that I've added. It's an empty table, but still, maybe I'm just playing around with this and I'm not sure what I want to do next. Great. So I have this additional branch that I am working on here, but just in case I need to make other changes to the main branch, I can simply go ahead, git checkout, master or main, depending on how you have it. So now I'm coming back to the master branch. And if I'm looking at the exactly same file, this file hasn't been changed on the master branch. So I don't have here the table, I only have my website. And just as well, if I want to go back to making changes, expanding that table that I have, perfectly fine. I can go again, git checkout. I don't have to specify -b as a parameter because I already have the branch. So it's feature/new table. And now I'm on the other branch. Typically, there are two things you will do with a branch. At one point, you will either give up on the development, whatever you've tried in that branch, and say, okay, this idea with the table is not working, so I'm going to go ahead and delete it. Or you want to keep that changes and to integrate them in the master branch. So if you consider that you no longer need a branch, what you can do is to run the command git branch -d to delete it, and then you enter here the branch name. In this case, you will get an error. This is a built-in protection that Git has. And it's essentially telling you, hey, this branch, you haven't integrated this anywhere. So if you delete it at this point, you will lose all the changes that you have. So if you haven't merged this already, you cannot delete it because Git knows you're going to lose the changes. If you still want to override this and say, I really don't want to have it anymore, you will have to use D with a capital D. And in this case, we'll force delete that branch. Now, I don't want to delete it. I think this table feature is still very useful and I want to keep it. So for that reason, I'm going to look into merging. Now, it's important to understand what is being merged where. Currently, I'm inside the feature new table branch. And I want to integrate this branch into the master branch. So for that reason, I'm going to switch to the master branch. So git checkout master. And from the master branch, I'm going to run the command merge. So this is super simple, git merge. And I have to specify the branch that I want to merge with the master branch. As you remember, the main development is happening on master. So for that reason, I'm interested being inside master and merging other branches rather than being inside a branch and merging the master. Both are possible, but typically what you're trying to do is be inside master and merge the other branches that we have. So I'm going to write here git merge feature new table. And this is essentially the merge that has happened. So if we're looking here inside git log, you will see here that this commit that was inside the feature branch added table is now also part of master. And you can say this is why it's showing you here at the head. You're currently inside the master branch. This is the top of the repository, if you can call it like that. And this commit is absolutely the same as the one you have here. Another aspect that I wanted to point out is the following. It says here fast forward. Now fast forward merge is a very simple merge and is only possible if you haven't made any additional changes to the master branch. Essentially, a fast forward simply means moving the commits that you have made on a separate branch onto the master branch because the parent from where this branch started is still the same. If, for example, you have made changes to the master, this merge method wouldn't have been possible anymore because then the parents would be different. So the master branch would have evolved in time later on, and your branch you have ported from advanced topic. I'm going to look into that in one of the following lectures. The last thing that I wanted to point out is now if we are running this git branch command, it will give us some information regarding which branches are available. So we only have the master branch and this feature new table. And of course, if I want to go ahead and run this delete command on the feature branch, is now possible because we've merged these changes into the master branch, so we don't need it anymore. So this is why Git is now allowing us. Next, let's take a look at a more advanced branching scenario. And I'm going to start again by creating a new branch. So git checkout -b. Let's say we're fixing a bug, so I'm going to call it bug fixed table. You know, this table that we created is not really showing anything, so we're trying to fix it. So this is the branch with table. So I can simply go ahead, edit the index.html file, maybe make some changes here to the table. Maybe add a table row. So again, a super simple change. I'm gonna go ahead and save it. Let's add this. Can run a git status to make sure we're modifying and committing the right file. So we only made some changes to the index.html file. Git commit. So I'm adding here a table cell. Great. Now, it may happen that while I'm learning about tables and how to make all these designs, there's something that needs to be changed inside the master branch. So I can go ahead, git checkout master, and let's say we need to edit the readme file. So I'm learning git, let's say, and merging. Okay, so I made another change here. And this is inside the master branch. So git add, I'm adding this change. Learning branching is my commit message. And now what happened here is that the master branch has moved on, but currently my other branch, the bug fix table branch, also contains a commit, but it is based on a previous version of what we're having. So a fast forward branch is no longer possible because we no longer have the same parent. We can still go ahead here and run the command git merge, and we can merge this bug fix. And when you're doing this, you're going to create a commit message. Now, essentially, this commit message is Git reminding you that you're doing a merge, and this merge is not a fast forward merge. This will result in a commit that will, let's say, kind of like merge the changes together because the branches have separated, they don't have the same parent. So this is why this commit message is necessary. So you can change it, but typically I'm just gonna click here on column X, I'm gonna save this. So the merge was still made, but you'll see here the merge was made by the recursive strategy. Now, I'm not going to get too much into this, but if you're running this command git log now, you will see here that you have your table cell commit. This happened first, historically speaking. Then in the master branch, you made this learning branching commit. And then finally, you have merged. So this git branch merge, this is where the merge itself happened. And it created this additional commit. Most of the time, you don't want that. And we're going to look into rebasing commits in just a second. So let's try to replicate the previous scenario that we had. And I'm going to go super fast over this. We have created a new branch. Let's call it bug fix table 2. Inside here, we're making a commit. So making a small change. I'm adding this change and I'm committing it. So I've added here a second cell to this table. And again, let's jump back to master and make another change inside master. Now, essentially, I can simply go ahead and change the same file. Just to keep things a bit separate, I'm just gonna edit again the README file. So I'm learning Git and merging and rebasing. Git add, learning, rebasing. All right. Now, again, there's something that has happened inside master. There's a new committer. It can also be 2 commits or 3 commits and so on. And our branches are no longer the same, so we cannot do a fast forward merge. Ideally, just to keep our history as clean as possible, we want to do a fast forward merge. These merge commits, they tend to be ugly. It's not always so nice. So if we can, we're trying to avoid these merge commits. Now, at this point, these changes that we have here, they're not conflicting with one another. I made some changes to the README file in one branch, in one commit, in the other branch, in the other commit, I made changes to another file. So there's absolutely no reason why we shouldn't be able to do a fast forward merge. The only thing is that we need to bring our history again in synchronization. So what we can do here is to go to our branch. This is the bug fix table 2 branch. And if you're looking here at the history, you will see here that we have the previous merge that we did, and now we added the second cell, but we're missing this other commit from master. But what you can do is to run the command rebase. Now, essentially what rebase does is it takes the changes from another branch, in this case master. If I'm running here git rebase master, takes the commits from master, adds them to the branch where we're currently at, and after that it adds our commit. It is like we made this change after the change that was inside master. So we're a bit rewriting the history, but since we are inside a branch, that's totally fine. So essentially, even saying here is replaying your work on top of it. It's like we've added the second cell only after the change in master. So if I'm looking here at log, we'll see here that now we have merge branch. This was where we started initially. And now we also have this newer commit that is inside master. You can see here, this is where the master branch is at. And now this other commit that we have is then put on top of it. Now, the nice thing about this is when we're going back to master and we're running git merge bug fix table 2, we're gonna get again the fast forward merge. And especially if you're working for a longer period of time inside your branch, either you're doing a feature or a bug fix, it is important to resync, to essentially integrate your work with whatever happened there. And we're going to take a look at resolving some conflicts in the next lecture. But essentially, if you can rebase your work with what's happening in the branch, it's great, because then at the point of merging, you'll have a very simple merge. The problem of handling merge conflicts is probably one of the most annoying things in Git. And a lot of users trying to get started with Git, trying to understand how to work with someone, especially if you're getting changes from your colleagues inside your repository and trying to integrate your work, you're getting these merge conflicts, it's like panic mode. And I'm here to reassure you that there's no reason to panic, because we're going to try to understand what's going on and how we can resolve this merge conflict. Now, first of all, what is a merge conflict? A merge conflict is a situation where you're trying to merge changes. For example, you're trying to merge these changes either by doing a rebase or by simply merging 2 branches together. And at one point, Git detects that 2 different commits have made a change to the same file, and not only to the same file, but they modified essentially the same line. And this is a point where Git is saying, well, I'm no longer comfortable automatically merging this for you because I have no idea what is the change there, what's supposed to be inside there. Now, most of the time, you can integrate a lot of changes, especially in large projects, all the time without a lot of issues. And especially if you're talking with other people, hey, I'm making changes to this module, I'm making changes to this file and so on. this can avoid getting into such situation, but still they are a normal occurrence. They do cause a lot of frustration, but we are here to get over them and to try to understand what's happening and why are these merge conflicts happening. So again, let's go ahead and do a few changes here. So I'm going to go ahead, I'm going to create a new branch. Let's call it again bug fix. So this will be the third bug fix on this table. And let's see here. Let's call this cell 1. All right, I'm going to save these changes, stage them, and also commit them. I've simply renamed the cell, nothing special, and I'm going back to the master branch where I'm trying to edit the same file. So let's say here that for whatever reason I've decided to call my cells now my cell. So I have here my cells, edited absolutely the same line, adding it, I'm committing it, renamed in my cell. Now, I have absolutely no issues making this change inside master, but now if I'm going ahead and trying to merge this bug fix, we're gonna get into this conflict. And first of all, when this happens, it's like, oh my god, what has happened? I don't know what I'm doing here, there's something wrong. I want to get out of here. Now, first of all, whenever something extraordinary happens and you don't know what's going on, you cannot leave your repository in this state. This is a state where you cannot work anymore. So you should stop making any changes, or you shouldn't continue with a Git repository that's in a conflict, okay? Because there are things there that you will not understand. Just to understand what's happening, run a git status. So git status will tell you where you are, it will tell you what to do essentially, and give you information like what's going on. And you will see here that there's something unmerged. There's a conflict there. The conflict is obviously inside this index.html file. And if for some reason you say, well, I don't want to deal with this merge right now, just get me out of here, it's not a problem. You also have the possibility of, aborting the entire thing. So this command git merge -- abort, git merge -- abort will save you the trouble, will restore the master to its original contents, will not affect any branches. Essentially nothing has happened. So this was like, we've tried to merge this, it's not working, we know it's not working, there's some issues there, but with git merge -- abort, we brought our repository in a state where we can continue working with it, but not with this merge. So that's the first step, and it's very important to know that you can get out of a merge, maybe get some help if this is not working directly, but you can get out of it. And now if you're running a git status, it will tell you, hey, relax, everything is good. You can get the same thing if you're inside the other branch. So if you're inside the other branch and running bug fix, so if you're in this other branch and you're running git rebase master, so as I've taught you, you're trying to all the time get changes from master to make sure that your development is working properly. Well, the same thing will happen here again. So when Git is trying to put the changes inside what you're having, you will notice here, oh, I can't do this because you have changed the index.html, the changes that are coming from master. So there's again a merge conflict here. So rebase can also generate absolutely the same thing. It even tells you here, git rebase -- abort, just in case you want to abort it. Git status will also give you other useful information, tell you what's going on. So I'm gonna simply abort it, but be prepared to get these conflicts either when you're rebasing or when you're merging. So I'm just gonna abort mission here at this point. And essentially this is how you get out of the situation. Now I can go back to master, or I can continue resolving the conflict inside the rebase. It is more or less the same thing. So let me go ahead with the merge here because we are essentially discussing merging. And let's take a look at this file where the conflict has appeared. So you can see here that the index.html file is the one that's causing some issues. And this is the part where a lot of people really freak out. We're seeing these things here with head, and they're like, what's going on? I haven't added this to the file. Why did they appear? This is causing really a lot of confusion. So let me quickly explain what's going on so that when you're seeing something like that in your editor, you're not totally freaked out and you know exactly what to do. Now, first of all, this is Git telling you that this part is affected. This part of this file is affected. If there are multiple conflicts inside a file, of course, you will have multiple of this notation that you see here. Now, what's happening here is that the first part says here head. Your current head is the master branch. It's like the top of the current branch where you're at. So this is like what you have in the master branch. And the other part, separated by the separator, is what you have inside the other branch that you're trying to merge. And it's even giving you the name of the branch. So this is master, essentially in our case. This is the other branch. You can see in master, we've changed it to my cell. Here we still have cell 1, cell 2. Okay. So this is why this is causing some issues here. So there are two lines affected, and Git cannot know what you want to do in this situation. Now, the way you get out of this essentially is by editing this file and keeping only the changes that you want to keep. In most situations, doing these changes in an editor like this is rarely the best solution, and it's for a lot of people, even honestly for me, in real life merge conflicts that are not so trivial, it is better to have your IDE open. And I'm going to show you how this looks inside Visual Studio Code. So if I open my project inside Visual Studio Code, it will automatically detect Git inside here, will know about Git, and will also detect here, you will see that this index.html file is marked in red. Most IDEs will identify that there's a conflict there, there's something wrong, and it will tell you, hey, look, you should really take care of this conflict before you change anything else. Because you're in this, essentially inside this merge process, and you need to complete the merge process before you do anything else. Now, as I said here, this is a nicer view of what's going on. And you might think, well, it's not so nice. Well, trust me, it is a bit nicer. And it also gives you some options. Now, most of the time, the options are the current change. For me, this current change is honestly a bit confusing, what's current and what's not current. But if you know on which branch you are, the current change will be what's inside that branch. Maybe you want the incoming change. So you can accept one version. You can accept the other version. Most of the time, it makes sense to compare the versions that you see here and to make your own judgment in terms of what you want to do. So you may, of course, without any issues, you can decide here that, okay, I'm accepting the incoming change, but at the same time, I'm adding here my cell. So most software projects, you want to keep some changes from both, so you want to make your own changes, you want to add your own things there. So this is where this editor can help you out. So we can go back now to the terminal, and if you run the git status command, well, you will still see that you're inside the merge. So just because in your IDE you have selected one of the versions or you made some changes, it doesn't mean that this merge process has ended. This is like the important thing you need to understand. This is why running the git status command all the time is super important to understand the status. So if you're looking here inside this file, now you can see I kind of have it the way I want it. So changes from both sides. So that's perfect. Now, what's important to understand is like we need to tell Git about this. And it says here unmerged paths. And it's telling us what do we need to do in order to mark a resolution. So essentially, we're telling Git, okay, this was the conflict, now I've solved it. So we're going to get here Git, add, and adding this file. And we also need to commit these changes because this is similar to the automatic merge commit that has been generated. In this case, we're taking over the process a bit, so we're responsible for this merge commit. I'm going to resolve conflict. Okay, and now we can see after this step, we have resolved this conflict. Now, the way Git works, if you're doing a rebase and you haven't rebased for a while, you may get, during a rebase process, multiple conflicts, because essentially, Git will play back the history with all the changes. So for example, you haven't rebased in a week and you're getting conflicts, you're going to get the conflicts in the historical order they occurred, even if they're no longer relevant. So it's not like one big commit that's happening like for the entire thing. No, for each individual commit, you may get a request to handle that change, and then the other commits will come on top of it. So expect something like this. This is why rebasing and keeping your branches like short-lived, not hanging around too much, can really reduce a lot of complexity in terms of resolving conflicts. But work with Git status, work with your IDE to understand and visualize the changes. Don't panic, but decide, do I want to bail out? Do I want to abort this merge? Do I want to go through it? But always make sure when you're making a commit, you know exactly what you're changing. Now we are entering the second part of this very short tutorial, and this is the part where we're starting to work with Gitlab. And just to give you a bit of a background, Git is a distributed versioning system. We can have local repositories like the one we also have remote repositories. Essentially, you can exchange your repository with others. You can make changes, merge changes. This is orchestrated by having this repository. This is orchestrated by having this repository. In the case of GitLab, there's not much different in concept how it works from any other remote repository. So if you already know how to work with GitHub, GitLab works pretty similar. What is very nice about GitLab is that it also has an integrated tool called GitLab CI, which allows you to test and deploy software, and this is particularly interesting in combination with branches. So first, you need an account with gitlab.com, or if you have a GitLab installation within your organization, you can use that as well. If you don't have an account, it's free to create, and the first step is to create a new project, which will essentially create a new repository. Now, what we're trying to do at this step is to take our local Git repository and potentially share with others. So for that reason, we're going to go here and create a blank project repository. I'm going to call it my cool website. And for the moment, I will keep it private, and I will not initialize it with a README file because I already have some local changes that I want to add. And if I already have a README file, that will conflict with it, so don't click this one. Now, this step of creating this repository is pretty similar to the git init command we have executed in the beginning. It's not much different. Now, what we're trying to do is push an existing folder. Now, essentially, we already have a repository, we just want to share it. So we already have this existing folder that I'm mentioning here. We already went through this git init part. So the next step for us is to add a remote. Now, adding a remote is essentially a way of telling it, by the way, you can exchange changes, you can exchange commits and branches with this remote repository. This is the distributed part of what we have there. So simply gonna go ahead and copy this. And here inside my Git repository, I'm going to simply paste it. So now I have added a new remote. Now, what's important to remember is that we're going to interact a lot with this origin. And origin is just an alias. It's just a short name for this entire thing that you have here. This is the address to the repository. Now, obviously, it's easier to keep in mind and to remember to work with origin instead of working with this. So origin is just an alias. You will see that we'll be using origin quite a lot. So this is why it's important for you to add this. Now, in order to move forward with this, the following thing is important. The way we're interacting with this remote Git repositories is by specifying an SSH key. So in my case, I've already specified an SSH key that I've generated locally. This is a way to work with these repositories without providing your username and password. If you haven't set up this yet for GitLab, in the video descriptions you will find tutorials for Windows, macOS, and Linux. The process is a bit different from all of them, but it is important that you have it up and running, just in case you're getting any errors regarding that you cannot read from a remote or you cannot push the remote, you don't have permission. It may be related to the fact that you haven't set up your SSH key. I'm not going to get into that right now, but it's important to know that. So now with git remote-v, I can simply check my remotes. So I can define multiple remotes. You can have here origin, but you can define anything that you wish. But for most cases, you will have your local repository and you will have this remote repository. The next step would be to generate a public and a private key. So the tool that we're going to use is called SSH Keygen. And this has been already installed as you install Git in the installation process. If you're getting any errors running these commands, try to restart the computer once. Sometimes in Windows, this may take a bit until everything is properly installed. Sometimes just restarting the terminal, that can also help. So I'm running this command, and this is essentially what's happening in order to generate this public-private RSA. RSA is the encryption standard that's being used. By default, it will be saved in your user folder. Mine is Valentine, and in this folder called .ssh. Sometimes you may not even see it if you're using Explorer, but it is there, and it's good to leave it there as a default path. So I'm simply going to click enter. I don't want to change that. The next step is you're going to be asked for a passphrase. So your private key can be additionally secured with a password, essentially. Now, unfortunately, setting this passphrase when using Windows is really a pain. And for simplicity reasons, I'm not going to set a passphrase. But essentially, to understand the security risk, if somebody gets access to your computer, if your files are not encrypted, and they can read this private key, which will be stored here in ID_RSA, they can get access to your repositories without being asked for any password or anything like this. But as I mentioned, under Windows, getting this to run without you being bugged to enter a passphrase every time you do something is, I would say, way too complicated. So we are just going to skip it for now. So we're not going to enter any passphrase. And this is going to be randomly generated for you. And this is cryptographic secret that is there. So this is essentially impossible to guess if you don't have the private key. So what has happened essentially is in this folder that you see here, there are two files that have been generated. One of them is this private key and the other one is a public key. Now, you can notice here that inside GitLab, if you don't already see this message all the time, like add your SSH key, add your SSH key, you can click it here to add your SSH key. In case you don't see it, you can go to your profile, go to settings, and from this menu on the left-hand side, you should be able to see SSH keys. And by default, you will not have any of them installed. So we're gonna copy our public key. We always share our public key with others, with servers, with GitLab. We never share our private key. As the name is telling you, a private key should be private to you. Otherwise, if you do that, then not only it will not work, but you'll also exposing yourself. So I'm gonna use a command, it's called cat. This will give us the contents of a specific file. So I'm gonna simply go ahead, copy the path here. And I was mentioning there are essentially two files inside there. So one of them is this ID RSA. This is the private key. And the other one is ID rsa.pub. And this is the public key. This is what we are trying to add to GitLab. You can use a text editor to get to this file, but because we already have the terminal here open, we're going to use that. So what I'm going to do is simply select the entire text that you see here, click on copy, and here inside GitLab, I'm going to paste it. I can even write here, this is for Windows 10 or whenever. It doesn't have an expiration date, so we can simply click here on add key. And this will be then saved, you know exactly when you created it. Of course, later on, if for some reason your SSH key has been compromised, you can go back here to your profile and click on this trash icon and you can delete it without changing your GitLab username and password. You know, just in case something doesn't work, you can play around with this. It's absolutely fine. So now we have informed our local Git repository that we want to work with this remote, but so far the changes that we have locally are not available inside the remote repository, and the reason for that is that we haven't pushed them. Now what we need to do is to push changes, and this is where this stage process that we have is being added another step. So we make a change to a file, we stage it, we commit it, but now we still need to push it in order to be available inside the remote repository and also to make it available for others. Now we already have a long list of changes here, so the next step is to use git push. Now if you're using git push here, you can set up your default branch to put it like that, but what I typically recommend when you're using git push is to be very specific about what you're trying to push. So for example, in this case, I really want to push all the branches that I have and everything, or I want to push only the master branch. So in this case, I only push the master branch. So git push, I'm pushing to origin. And as you remember, origin is this address here. So I'm pushing to that repository. And what am I pushing? I'm pushing master. So this will take a few seconds. And if everything is successful, you will get this message telling you that this information has been pushed. If I'm going back to the repository itself, hitting the reload, I'll be able to see here that the changes have been pushed and all the files that I've created are available inside here. So let's take a minute to explore the GitLab web interface, because it is a nice way of looking at what has happened inside a project without actually getting a copy of that repository. So there are many things that you can do through the interface itself, and this is by no means like a full tutorial of what you can do, but just to give you like some ideas of what's possible and what's not possible. Now, first of all, and this is like the general thing that you may be interested in, is to look at the past commits. So you'll see here that there are already 15 commits inside this repository, and you're noticing now that generally it's a good idea like to give a meaningful commit message, because if you're not giving it, it will be very hard to identify what was at that point where I started creating the table, or when I had this cell, or when I did something. So you will see here a list of all the commits. You can click on them, and then you will be able to see like what has changed. For example, in this case, this line has been removed and has been replaced with this. So this gives you a very nice opportunity to look inside these changes. Of course, you can click inside this editor and maybe write a comment and collaborate with others. So essentially GitLab from this point of view is also collaboration tools in terms of this. You can see the commits, you can see the difference between the commits. This is an inline diff, but you can also have like this side by side to have one version there and a changed version there and look at those. So that's definitely a very handy feature that's available. But also currently you're here inside a master branch. I haven't pushed any other branches in this case. So you're only seeing the master branch. just in case you want to work on this project only from GitLab itself, you can go ahead and create a new branch by simply clicking this, and you'll create a new branch. You can add new files. Of course, when you're adding a new file, you're essentially creating a commit. Many of these Git operations that we did over a terminal, you can do them from here. You can add files, you can upload files, you can navigate between all these branches and many things like that. When you're clicking on some files, if they have a specific version, you'll be able to see here like the raw version, so what's going on without it being rendered. Or if it's in a markdown file, you will see it in a different way, or for HTML files. So there are different things that are available and very nicely displayed here over the interface. You also have this editor, so you can click here on edit and edit an existing file. You can use the web IDE. It's a more advanced way of, you'll see the entire project and you can change files. This is very useful if you're trying to just quickly make some changes without getting everything locally. You can download files. So many features that are available inside here. You can also navigate here from the left-hand side, files, commits, branches. Tags is just a way of going to a specific commit and saying this is version 1 that's going to be released. We're not going to go into tags. But it's good to know about the web interface and what's possible. So now, since we have this web interface available here, let's go ahead and make a small change. So let's say I'm here inside the index.html file. I'm going to click on edit. And let's simply go ahead and create a third cell inside our table. And this will be again the commit message, added. You may say that this is a much nicer way of working with Git. I would agree. As you can see here, there's only one thing that you can edit through this editor. So you made a file, you change it, you make a commit. Through the web IDE, you can take probably multiple files, changing, and only then have it committed. So understanding these concepts of staging and committing and pulling is very useful at this point.
Dale like, suscríbete, compártelo para que más personas puedan aprovecharlo. Nos vemos en otro video.